Okay, recording. Nice one. Okay, so let's have a wee look at, so I'm on the booklet again. Okay, so starting with the booklet. And I said to you, we've got working with simultaneous equations, and there's loads of examples to go through, okay, in practice. What I'm going to look at tonight, just for half an hour or so, is just working with some simultaneous equations exam questions. Okay, now my assumption with that is these are all past papers. I've not had to look at all the past papers and put them together and figure out which one's which. But if they're not, they're exam level questions, okay, so the sort of type that can come up. So I'm going to walk through question 2. Okay, so if you've had a go at this, fantastic. If you've not, I'm just going to walk through this just to get us back up to speed with those rules again in the format. Okay, so simultaneous equations, we're looking at story type questions that come up. Okay, so concert hall sells 2 types of tickets. Okay, so these are 2 unknowns. So we're taking that straight out of the question. So we're going to have 2 unknowns, stall tickets and balcony tickets. Okay, now in an exam, you don't have to write this out, but I'm just going to put them out just so I can assign a letter to them. Okay, oh. So I've stall tickets. I'm going to assign the letter S to that. Okay. And then we've got balcony tickets. I'm going to assign the letter B to that. Okay. So remember, letters we use are just there to position something. Okay. These are our 2 unknowns. Okay. These are our 2 unknowns that we want to do simultaneous equations for to figure out. Okay. So to do that, we need to find 2 equations. So looking back at the question, it actually splits that into A and B. So it gives you an A part. Okay. So it said let S, well, in fact, it gives you the letters to use. Luckily, I've used the right ones. Okay, so let S be the number of stall tickets, B be the number of balcony tickets, okay, or unknowns. From the information, write down an equation connecting S and B, okay. From the information, so it's talking about the information above, and it's saying when all the seats are sold, the concert hall holds 640 people. So when all the stall tickets are sold and all the balcony tickets are sold, it's holding 640 people. Okay, so if we go back to, so venue holds, I'll share my screen in 2 seconds. Just writing this down so remember. Okay, so we go back into that. So we've got S, stall tickets, balcony, B, venue holds 640 people. Okay, so question A, put a relationship down. Okay, so essentially we've got S plus B equals 640. Simple as that. So stall tickets plus balcony tickets equals total venue. Okay, nice and simple. It's the only data we've got so far in that question. Okay. B, slightly trickier part of it. Okay. So on a particular night, concert is sold out. All the seats are taken. Okay. Stall tickets priced at £8.50. Balcony tickets, £12.20. Okay. The total takings at the box office is 6143. Okay. Now, what might throw you is the fact that there's nothing to say anything about money in that first part of the question. Okay, but it still makes sense if you think about it. If we sell all our tickets, okay, so all seats are taken, so we need to sell all 640. Okay, the stall tickets have a price of £8.50. Okay, so that's one of our sort of numbers we're putting in front of the variable. The balcony tickets, £12.20, and then we've got a total. Okay, so I'll just write that down so I don't remember it. Stall, so I don't remember. Okay, so let's see how we write that out. Okay, so blah, 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 blah. Write down this information in the equation. Okay, so we're wanting an equation again. Okay, it's wanting to have the letters S and B in it. It's wanting to have all that data we've just read. Okay, so yeah. Okay, so what's that's telling me? If we sell all the stall tickets at £8.50, and we add on all the money we take from the balcony tickets, which cost £12.20, we're going to end up with that total. Nice and simple. Okay, so all the information's there for me. It's not trying to trick us. Okay, seems pretty reasonable. So, part C. Find out how many stall tickets there are and how many balcony seats there are, okay, in the concert hall. So effectively work out what S and B is. Okay, and that's where we're going to do our simultaneous equations. Okay. So first equation, equation 1, S plus B equals 640. Okay. Then we've got 8.5S plus 12.2B. Okay, so I've not put in this final 0. Okay, we don't need that. It's not telling us anything. Okay. Likewise. Okay, we're going to convert it back into a monetary value at the end. So we'll put back in the sign and we'll make it 2 decimal points. Okay, but at this point, that second decimal point's not telling me anything. Okay, and that comes to 6143. Okay, so we've got two simultaneous, so we've got two equations, sorry. Okay, 1 and 2. Okay, we've got them in the right format that we want. So all the letters are on the left-hand side and the whole numbers are on the right-hand side. Okay, so we've got the perfect format. We've got two equations. Now we just need to work through and solve. So to solve, we're wanting to cancel out one of those letters. Okay, so I always said to you on Tuesday, just cancel out that second term. It usually works out to be the easiest. Okay, someone did ask and I said you could cancel that out. If it's really obvious that cancels out, then that is absolutely fine. Okay, I'm just trying to stay consistent with what I'm telling you, so not to confuse, I'll just try and cancel out that second term. Okay, so to cancel out that second term, we need the number in front to be the same on both lines. Okay, so for the number in front of the B in equation 1 to be the same as equation 2, we need to multiply that whole line by 12.2. Okay, so that whole line gets multiplied by that. Oops. I'll throw my calculators beside me. Okay, so if we multiply that whole equation by 12.2, and this would have been a calculator question because you are not multiplying 12.2 by 640. So that first line, okay, that we've multiplied by 12.2 becomes 7808. That allows us to make it the same number as below, so we don't need to do anything now to that second equation. We don't need to multiply it by anything. Okay, now to eliminate that second term, we take away that second equation from the first equation. Okay, so we do that in a vertical, that's why we put it in this format, we write it out like this. Okay, so 12.2 minus 8.5 times 3.7. My God. Second terms cancel each other out. So 12.2b minus 12.2b cancels each other out. Last term, 7808 minus 6143 becomes 1665. Okay. So we just go through, we solve that. Okay, so just put it a little closer together. Okay, S equals 1665 divided by 3.7. So S will be 450. Now, a good way to sort of sense check yourself at this point, does that make sense? Okay, so 450 seats in a theatre, yeah, that makes sense. If you had an outrageous answer, if you had something in 20,000, okay, that's an outrageous answer for what it's asking, or if you had something like 6, okay, again, something's gone a wee bit awry, okay. So sense check yourself at this. If it gives you a story, the answer is going to be in line with what you sort of expect, okay. So 450 seats in a theatre, yeah, that makes sense. All right, so I'm happy with that. We take that number, we substitute S into equation 1. Equation 1 is nice and easy to do that. Okay, so equation 1 was S plus B equals 640. Okay, S we know is 450. We substitute that in to that position. Okay, so where you see an S, we substitute that in. That's just 450 plus B equals 640. B, therefore, 640 minus 450. $190. Okay, so 450 stall seats. 190 balcony. Okay. Remember the format it's looking for, so it's looking for the amount of seats, so it's just a whole number. Okay, it's not asking you cost. Okay, just have a wee check. That's what it's asking. Hence, how many blah blah blah. Perfect. Okay, so we've answered the exact question. Super. Okay, guys. Any questions? Any uncertainty then? Okay. Anyone try a question that they weren't sure of over the last couple of nights that want to share with the group, or we can go through? Okay, so what have we got? 2, 4.
I did, Daniel.
Yeah, go for it, Sam.
It's the kilogram one.
Whoa, blah, blah, blah,
I
blah.
think it's postage, parcel and a box. I couldn't work that one out at all. Is that number 12 or 13, I think?
Oh, she's got quite far then. Is it one of the exam ones?
I think so. It was on those ones that we continued on page 22. Carrying on. I couldn't work that one out at all. I worked all the others out, but I couldn't work that one out.
Oh, perfect. Oh, that's 20 minutes is really nice and easy for you then. 20p, 20p, 12 or 13. A van carrying 8 identical boxes.
That's it. That's the one.
Right, let's have a wee think about this together. This is a risk. I've not looked at this.
Right.
Chancellor. Right, let's have a wee look at this together before we go into our room. Okay. In fact, I'll not share it. Okay, so van carrying 8 identical boxes and 5 identical parcels. Okay. 8 boxes, plus 5 parcels. Let's start with that. 3 boxes and 2 parcels weigh 22 kilograms, and 4 and 3 weigh 30. Right, okay, no problem. So what this question does is tries to throw you at the start. Okay, so this 8 and 5 at the start, you don't need it until the end. Okay, so what your simultaneous equations are made up with is the information in part A. Okay, and then part B takes into account what this 8 and the 5.
Right.
Okay, so your simultaneous equation should be this. Okay, that's unknown. Okay, so let me just write this down. So 3b plus 2p 4b plus right. That's the 2 equations. So ignore that one. Okay. That one we use in part B. Is that the 2 equations
Yes.
you got? Okay. So let's have a wee look. So multiply that by 3, multiply that by 2. That'd be 9b plus 6p, 66. 2 would be 8b plus 6p equals 60. Minus that. Okay. That would give me 1b. That would cancel that out. And that would leave that as 6. Okay. I'm going to sub b equals 6 into equation 1. Okay, so equation 1 was 3b plus 2p equals 22. B equals 6, so 3, 6 plus 2p. Okay, so that's 18 plus 2p equals 22. 2p equals 22 minus. Okay, so I've got a box, 6 kilograms, a parcel, 2 kilograms. So far. So in the van total, there's 8 boxes plus 5 parcels, and that equals an unknown. Okay, so we've got 8 times 6.
Oh, right.
Plus 5 times 2 equals unknown. Okay, so 8 times 6 is 40. No, it's not, it's 48.
Yes.
Plus 10. That equals 58. So it should be 58 kilograms total.
Right.
That was.
I got as far as 48 and 10, but I wasn't sure whether that was actually right. I multiplied it by the 8 identical boxes and the 5 identical parcels, but I wasn't sure whether that was right or not. I did work all the other hours and got right.
Let's have a wee look. So is that not what it shows at the end?
I didn't even look at the end.
Those answers? Do you not know that?
I didn't know.
How do you feel? Let's have a wee swatch. Let's have a wee swatch. My God, a big booklet.
No wonder you can't find them.
There's a quicker way of doing this.
Mhm.
My God. Right, wait a second. Right. These are the answers. These are the answers. These are the answers.
Are we all store tickets, balcony tickets? So we should be somewhere around there.
Yep, 58 kilograms.
Oh, right. Oh, so we did get it right then. Oh, that's okay.
Yeah, have faith
Thank
in
you.
yourselves.
Thank you.
Have faith. Nice one. Superb. Okay, well, there's another example for you guys, so that's pretty good. Okay. 1, 2, 3, 4, 5, 6, 7, 8. How did I manage to lose 2 people? It's something I said. Okay. That's chunked into a bit of time, so but I still want to give you 10 minutes or so. So how about I give you a wee breakout room for 10 minutes? Have a wee go at some of these, okay? I've got noted down, don't try question 4. Why have I got that? Ah, because there's a percentage in it. Okay, so don't do question 4. Have a wee go at question, even if it's 1 and 3, or have a go at questions 5 and 6. Okay, I'll just give you 10 minutes, so we'll come back together at 42. 1, 2, 3, 4, 5, 6, 7, 8. I'll just split you into 2 rooms. Have a wee go at that. Let's have a wee move on. Okay, we're going to talk about something called functional notation. Okay, essentially, functional notation is just writing out an equation in a slightly different format. Okay, so it's just reformatting it. But as I say,
Sorry, could we read that again? Functional what? Sorry.
notation. So 2 seconds. So, so functional notation. Okay, and notation just means writing a function out in a slightly different way. Okay, so this is usually a wee one. It's usually like maybe a 2 marker. In the exam, it always comes up, but it's one that almost feels like a space filler rather than a proper question. But essentially, what it is just taking the equations that we're used to. Okay, so up until now, the equations until now have been in the format of y equals something. Okay, so y equals x plus 2 or y equals mx plus c. Okay, that type of format. What functional notation does, okay, it changes the format. So instead of y, okay, that original variable, we put it in the form fx equals. Okay, so all that means is f just means it's a function. Okay, and the letter in the brackets, and that letter can change. I've just put fx because the x is the most common. That, okay, that's just the function of that letter. Okay, so that will be the variable in the equation. Okay, so instead of writing it 2x plus 9, we can write it in the same. Okay. It's the same. Okay, so it's just a different way of writing that first sort of variable. Okay, so instead of writing y equals, we're writing function of x equals and then that. So that letter in the brackets is going to be the variable in the equation. Okay, so it doesn't have to be x, it could be a. Okay, so function of a, and then the variable in the equation would be a, or function of s, and the variable in the equation would be s. Okay, so those letters should or will line up. Okay, so it's a function of whatever variable. And it's just another way of writing it out. Okay. Key points when we're going through questions. Okay. The character in the bracket. Okay, we got the input. Okay. That's the number we put into the equation if we swap out that letter for a number. Okay, so let's put that into context. If we've got fx equals 2x plus 9, okay, and we want to see that. Okay, everywhere you see an x, you'll write in the number 3. Okay, so f bracket and then they put in a number, that would become that. Okay, so we've substituted that number in there. So in functional notation, if we wrote f bracket 3, writing that out, okay, just solve that through. Okay, and that's just solving that equation. Okay, so whatever goes into that bracket, if you see it in this form, is inputted, substituted in wherever there's a letter. So that bracket just indicates the variable, and there's a number in there. It just indicates we want to put that number wherever we've got a variable in the equation. Now, another way you might see it written, okay, is it gives you a function. And then asks you to solve what the input is. Okay. Okay, and then asks you to solve for x. Okay, all you would do in that instance is have 15 equals 2x plus 9. Okay, so what we're saying there is fx, so function of x equals 2x plus 9, function of x also equals 15. That means 2x plus 9 must equal 15. Okay, so that would be one question. Okay, put that in on setup. Okay, and then solve for x. Okay, so you can leave x on the right hand side. First one you bring over is that 9. 15 minus 9 is 2x. Okay, so that'd be 6. Okay, or we could write that as x equals 3. Okay. That and that means the same thing. Okay, so that's the two ways you could see this question written out. So either it gives you something in the bracket and it asks you to then solve that equation by substituting in that number, or it will give you an output, okay, of what that equation will equate to, and then ask you to find out what that letter. Okay, so essentially working backwards from that. Okay, so let's go through an example. Okay, we've got, okay, we'll use the same function for all of these. Okay, so we've got f okay. Just be 6 multiplied by 2 minus 4. Oh, don't know where I got that 8 from. I was thinking of the answer. B, even if we just throw in a negative. Okay. Okay, so nothing changes if we throw in a negative in there. Okay, so just watch the sign, just be careful with that sign. So it's just 6 times negative 3 becomes negative 18 minus 4, which is negative 22. Okay. If we have f is a function, x equals 40. Okay. We just equate that. Okay, so it's giving you the output. You want to find out what the variable is. Okay, so f is a function of x. Okay, when it's 6x minus 4, that minus 4 moves over. It's a negative on the left-hand side, so it becomes a positive.
Sorry, can I just ask a question?
Yep.
Where did you get the 6x from?
Well, we're still using the same expression. Still using this, sorry.
Ah, right, okay. I was still confused with where we were going with this there.
No,
Right, that's fine, no worries.
I could just build it. No, we're still using that same expression. So instead of getting something in the bracket that we're then putting in the expression, we're taking that expression, we've been given an output, and then we're equating that 6x minus 4 to that output. Okay, so when you see it written out in this format, okay, you've got f bracket, a letter equals an output. We're taking that output and equating it back to the original expression. Okay, so that's all I've done there.
That 8 is wrong, isn't it? It should be 4.
Why did I write it as 8? I did it in that question there as well. It's weird, but thank you. Okay, bringing that 6 over, it's a multiple on the left, so it becomes a divide. Okay, so x is equal to 3. Okay. Let's just have a wee 10 minutes just so we can get ahead into it. We're actually going back a few pages in the booklet. I'll leave my page up. Okay, so functional notation. Find FE. That? Okay, so 1, 2, 3 is fine. Okay, so we've been on for an hour, so we can take a wee break as well. If you have a go in the booklet, okay, and if you do question 1, A and B, question 2, A, B, C. Okay. Try C in question 1 as well, actually. Just see if you can. It's not a trick question at all. It's just a wee tiny complication. Okay, so A, B, C in question 1 and 2. Question 3 is the same, so let's try and skip. Skip until question 6. So we'll have a go at question 6. 7 is fine. 6 and 7. So do question 1, 2, 6, and 7 in that booklet. Okay, I'll leave my page up. Okay, you might have to squint a wee bit. In fact, you know what I'll do? Now, cut out any confusion. Just remind me not to hit save. I'll remove them because they're rubbish. Okay, have a wee go at 1, 2, 6, and 7. So let's say work for 15 minutes and then take a wee 15-minute break as well. Okay, so we'll come back together at 7:30. Okay, so I'll keep that sharing. Stop the recording. Something. Record that. Share again. Boof. Okay. Boof. I think I've ever said boof in my life. Okay, nice one. So couple more examples. Just want to see. Okay. Just to show where it can go, where we can take it. Okay. They don't tend to do over too much with this. Okay. They like throwing in.
Excuse me, Daniel, the exam question, will that have functional notation written in it? Or abbreviated to some way in the question? How do you recognize it? Just FX?
How would you recognize it?
Just FX. Okay,
Yeah,
thank you.
so just the FX or F letter. Okay, so if it has a letter in there, that's what it's after. Okay, so that would be a functional notation. It would just be something along the lines of solve for X. Okay, good question. I'll get a couple more past paper questions, but yeah, it won't say solve this functional notation, but it should be pretty clear with that FX. Okay, so there was actually a square term in those examples that we walked through, so hopefully should be okay with that. So all these examples, I'm going to use that expression. Okay, so F2, F7. Okay. Fs equals 90. So they might change the letter, okay, but again, don't be worried with that. D F 3F equals 90. Okay, so I'm just going to run through those examples. Shouldn't cause us too much of a problem. Okay, so A. All of these will use that expression. Okay, so A F2 equals 2 squared plus 9. That's just 4 plus 9. It's 13. Okay, so there's nothing different in the way we treat it. It's just substituting that number in. Okay, F7. Again, just 7 squared plus 9, 49 plus 9. It's just your 58. Okay. Sometimes they'll say for that expression, Fs equals, or F in another letter equals that. All they're looking for you to do is write that expression out, but with S in place of the X. Okay, so just a wee slight change. Okay, so they might use a different letter in that expression, just change that expression to suit that. Okay, so the input is the important part there. Okay, so we're using that same equation, but we're putting in the letter S and we're solving for S. Okay, so moving a squared term over to the other side, it becomes a root. Okay, root 81 becomes 9. Okay, and we'll do a couple more roots later on. Okay. With that, question D, okay. It's question D. We're still got the same expression, okay, so we're still treating fx equals x squared plus 9. I'm just writing that so I've got it in front of me. Okay, so in f, 3f, okay, equals 90. In place of that x, just substituting that 3f in, and then we're equating it to that output, which is 90. Okay, so in place of x, putting 3f, that becomes squared, plus 9 equals 90. Okay, I'm squaring that whole term. Okay, 9f squared plus 9 equals 90. And then just go through it as if, oops. 9, yeah, that's right. Okay, remember when we're solving these, we're following BODMAS. Okay, so when you're rearranging, BODMAS is going in reverse. Okay, so we've moved the add and subtract over first. That's what we did there. Okay, second, we're moving the multiply. So we move that 9 before we move the squared term. Okay, so we're moving that 9 across before we move the squared term. That should be squared. 81 divided by 9 is 9. Now we can move the squared term. We move that last. Okay, it's a wee bit more to do. Important part here is this step. So we're squaring that whole thing. So don't just write 3f squared. Okay, it'll be squaring everything in there. Okay. And then the moving there. Okay, so that's just a square term. If we've got, say, a cubed term, we look at that. If I jump ahead, shout on me and we'll go back. Okay. Dealing with a cube term, nothing changes. Get away. Okay. So we've got okay. When you're solving an equation, we're using BODMAS in the correct way. Okay, so we'll do the orders first. So 2 cubed. Okay, remember what that means. Just means 2 cubed just means 2 times 2 times 2. Okay, 2 times 2 is 4 times 2 again is 8. Okay, so it's left with 5 times 8. Okay, and then we're doing the multiple. 5 times 8 is just 40. Okay, just remember just to follow that. Okay, so the first thing we come up against that order. Okay, so the order or indus. Okay, so sometimes you'll see it written as BIDMAS. That there's just the indus or the order. Okay, so if you're going left to right when we're solving, brackets, indus, divide, multiply, add, subtract. That's the way we're doing it. Okay. Just another one, just to throw it in there, just so we're comfortable. Okay, so something like that you'd be expected to know without a calculator. It's 4 times 4 is 16. Okay, times 4. Okay. Remember, you can break that down, make it a wee bit simpler. So you could do 10 times 4 plus 6 times 4. Okay. If I was doing it in my head, that's the way I would do it, and that would just give you 64. So you don't have to do 16 times 4 straight off the bat. Okay, you can break that up. Okay, does that make sense what I just did there? Okay, so 4 times 4 times 4, we would be expected to do something like that in our heads. Okay. So 5 times 64. Okay, again, quite a tough multiple. What's the easiest way to do this? I would multiply that by 10, divide it by 2. Give me 320. Or if I had to, I would just do 64 plus 64. Just do it the long way. Okay. So that'd be 128 plus 64 plus 64. Okay, so if you, I don't think they'd give you anything like this in a non-calculator, but if they did, there's different wee ways of just working it out and just checking your answer. Okay. Through that. So that should give you 320. Okay, let's have a wee think about if ft equaled 135. Okay, so we're getting different letters of input, but we're being given our output. Okay, so we're substituting that letter in and where the x is. Okay, and then equaling it to 135. So we're just writing 5t cubed equals 135. Then it's just a case of rearranging. Okay, again, because the bod mass. We're rearranging this time, so we're going reverse, so we're going right to left, we're going that direction. Okay, there's no add and subtracts. So the first thing we want to do is deal with the multiples. Okay, so the multiple moves over, leaving us with t cubed. 135 divided by 5.
Daniel, can you just go back a step, please? Where did you get the 5 from?
That's coming from our original equation. Okay, we're using that expression. That whole
Right,
thing.
okay. Yeah, I get it now. Thank you.
Okay, so that's the second time I've done that. Okay, so our original equation was our fx 5x cubed. Okay. Okay, so we're putting in that t where the x's are, equating it to that 135. So t cubed equals 27. Okay, that'd be quite difficult. I'd reckon that by a calculator. So 135 divided by 5, 27. Okay, then we're moving that cubed root over. Okay, just remember how we write it. It's a root sign with a wee 3 outside it. Okay, what that tells me is what 3 numbers multiply together to make 27. Okay, so what 3 numbers multiply together to make 27? Okay, and you can go through it if you want. 1 times 1 times 1 is 1. 2 times 2 times 2 is 4, 8, 16. No, it's not, it's 8. 3 times 3 times 3, 9 times 3 is 27. Okay, so the answer is 3. Okay. Just another one similar to that. Okay, so we'll start. We'll write it out this time. Start with our expression 5x equals 5 2. So the function of x equals 5x cubed. Okay, we want to know, and we've got v in there, and that's equal to 625. Okay. Divided by 5. Oops, sorry. Okay, then we start moving that across. So our multiple goes first. Rearranging, we're going right to left. There's no add and subtract, the multiple goes first. Okay, v cubed equals 625 over 5. Is that solution? 125. I wouldn't just try to think if I should advise you if that's something you should know. What I would say is there's probably in your non-calculator some regular or common cubed roots might come up. I'd say like 1, 2, 3, 4, and 5. So 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. So recognizing 125 is 5 cubed could be beneficial. Could that come up in your non-calculator? I'm going to say yes. Okay, so just be aware of that. So that moving that cubed across. Okay, so your cube root. 5 times 5 is 25 times 5 again equals 125. Okay, so the answer is 5. Okay. One other thing I could throw in there Okay, and this is the past paper question. I stupidly not put what past paper it's from. So apologies for that. Okay, so past paper question. Okay, give you this, fx equals 2 over root x. So it could combine another part of what we've done in another unit. Okay, so this is bringing in surds. Okay, so when we work with surds, okay, it's actually a very simple surd, and it will just ask you to, in fact, it'll express as a fraction. Okay, don't worry if you don't remember how to do this, if it doesn't come back to you immediately, don't worry about it. Okay, I'm just throwing this in there just so you've got that awareness, okay, later on. Okay, as a fraction with a rational denominator. Okay, and if you remember back, denominator. Okay, if you remember back to when we were doing surds, okay, a rational denominator is just a whole number. So that surd, that root, is getting moved to the top. Okay, so let's just follow through the process. So f5 equals 2, and we're substituting that number 5 in to where there's an x. So 2 root 5. Okay, that's not the end of the question. They want us to put it a fraction with a rational denominator. Okay, a rational denominator means we need to get rid of that surd sign. Okay, that's down the bottom there. Okay, we do that by multiplying both the top and the bottom by root 5. Okay, so the top line becomes 2 root 5. The bottom line becomes 5 times 5. Okay, or 2 root 5 root 25. Okay, and that root 25 simplifies down to 5. Okay, and that's what it's looking for. Don't worry if you don't remember that. Okay, if you've not looked at surds for a few weeks, that won't be in your head. Okay, simply putting that there just so you've got that example when you're looking back over your notes, what could come up. Okay, so if you don't see that in the past paper, that has come up in the past paper. Stupidly never wrote which past paper it came up in this. Other ones that could come up, and I've seen that. This a+3 in its simplest form. Okay, this one here. Now, not seen it come up in a past paper. However, could it? Yeah, why not? Okay, so we think about what that's asking. If we substitute that, okay, so I'm looking at 9b here. Okay, we substitute that in there. It's just a case of breaking the brackets, multiplying it all out. Okay, multiplying that all out, and then collecting like terms and tidying it up from there. Okay, so it's probably worthwhile doing. Okay, there's no reason why something like that couldn't come up. Okay, so I'll just copy that down. They like to combine functional notation with another part. Okay. F. Okay. Same thing. So anywhere you see an x, a+3. Okay. And then it's just a case of working through and splitting up that bracket. Okay. a+3 squared. All that means Just doing that. Breaking that bracket there. Okay, in fact, yeah, let's do that. Okay, did anyone not see where that came from there? Okay, then it's just a case of doing FOIL first. Again, if you don't remember this process, don't worry. Okay, first outside. Inside. Last. And then it's just a case of collecting all the terms up. Okay, so remember, the terms that we collect, a like term has to have to be the same power. Okay, so an a squared can't go with an a. Okay, and a whole number can't go with an a squared type thing. Okay, so there's only one a squared. There's one 3a, 3a, and there's a 2a, so that's 6, 8 a's. And then plus 15. Okay. I would leave it there. Okay. The answer might ask you to factorize that. I'll have a wee check to see if there's anything that like that's come up and what it really asks for mark wise. That's collected like terms. Okay. Wouldn't expect to take that any further. Nothing to say that something like that could come up. Anything else outrageous? There's another one of those type. Okay, slightly easier one there because there's not a squared. Have a wee bash at that if you want. Okay. So interestingly, in the handout, in that booklet, there's no subs. Okay, but it definitely, that's why I put that in there, because it's a past paper question. Okay. That is functional notation. That's the extent of it. Okay, so not too bad at all. I say. Let's take a wee 10-minute break, just a wee refresher, and then we'll do the last thing of tonight, which is essentially focusing on BODMAS and just making sure we're comfortable with it for slightly more complex formula. Okay, so let's take a wee 10 minutes. So let's come back together at 8:10. Did this. Well, tough. Okay, so the length of that line is actually really important. Okay, so when I've brought that 6 over, that has to divide this whole y minus 9. Okay, you don't have to, sometimes easier if you put a bracket. That's not mathematically incorrect. Okay, it's just a wee reminder that, okay, that whole term is actually divided by that. And when we rearrange some of those, when it's in that form, okay, I'll remind you of that as well. Okay, it'll be a wee reminder. Okay. As I said, in the exam, they like to use other letters. Just because it's other letters doesn't mean the process is any different. Okay, so if we want to rearrange z equals 5t plus d, okay, and we want to find the t, we follow that same process. Okay, if you're more comfortable with the letter you're trying to find being on the left-hand side, just flip it round. Okay. Both of those expressions mean the same thing. Okay. I think I've done it before. It's just the same as writing 5 plus 1 equals 6. Okay. You can write that as 6 equals 5 plus 1. You can just flip it around. Okay, it's the exact same thing. Okay, so don't be worried with the other letters. We're doing the same process. Odd mass, we're just reversing it. First thing we're looking for, any add and subtracts. Okay, yep, that comes across. Okay, any divide or multiply. Yep, that comes across. Divides that whole thing. Okay, so just watch the length of that line. That has to go under all of those letters. Okay. And I say that because if you move that 5 across and wrote it like that, that does not mean the same thing. Okay, that does not mean that. Okay. So that 5 has to divide all of that Z minus D. Okay, let's throw another one out there. Okay. Get rid of that. If we look at P equals 4RT minus 2M, okay, and the variable that we want to isolate and we want to keep on its own, that's an R, by the way, not a V. Is that R? Okay, so we want to tidy this up. Okay, so I'm going to flip it because I want that R on the left-hand side, just so it's a wee bit neater when we get to the end. Okay, so it's a wee bit easier to understand. So I'm just going to flip that 4RT minus 2M equals P. Okay, and we're still finding that. So now as R's on the left-hand side, it just means it's when we get to the end, it's just R equals so. Okay, so odd mass. Going from left to right because we're rearranging. Okay. First thing we're looking for, any add and subtract. Yes, there's a subtract sign there. Okay. Now we're subtracting, but it's 2M. Okay. Now you might look at that and say, does that not count as a multiple? What point do we do that? Okay. But because that subtract is there, we're taking that whole term, that whole 2M goes to the other side and it stays the same way. So it doesn't become a divide or it doesn't change at all. It just becomes positive. Okay. So we're taking that whole term, moving that to the other side. And it becomes that. Okay, so that subtract, okay, is what we're looking for. Subtracts 2M, so 2 of the M's goes to the other side, it becomes positive. Okay. Second things we're looking for is divide and multiplies. Okay, so we're wanting to isolate R. Okay, we're wanting to leave R on its own. So we want that 4, which is multiplying it, and that T, which is also multiplying it together. Okay. Now remember in algebra we don't write it out, but essentially that's just 4 times R times T. Okay, so we're just moving 4 and T over to the other side, and they're both becoming a divide. Okay, so the 4 and the T can both be moved at the same time. Okay, to leave R, P plus 2M. Whole thing's been divided by 4T. Okay, again, the length of that line becomes very important. It has to go underneath that whole term on the right-hand side. The 4 and the T are both multiples on the left-hand side, so they're both divides on the right-hand side. But you see the 4 and the T, It's now a denominator. It's still in the same order under that. Okay. Let's do something similar. What's my doing wrong? If someone doesn't follow anything or it doesn't become apparent, okay, tell me to slow down or tell them just shout and give me a wee heads up. Okay, so do something similar but with a wee negative sign in there. We've got T equals 5m minus 3pb. Okay, and we want to leave or isolate, leave b. Okay, again, get b onto the correct side so we're more comfortable with it. Okay, and we'll just write it 5m minus 3pb equals t. Okay, both mean the same thing. We've not changed anything there. We've just swapped the sides. Okay. We want to clear everything away from this 3pb. Okay, so again, we're doing BODMAS. Nothing's changed there. It's the time. We're rearranging, so we're going right to left. Is there any add and subtract? That's the first thing we're looking for. Yes. Okay. That's 5m gets moved over. Okay. And it might throw you the fact that we're just left with negative 3pb. Okay. That 5m is positive on the left-hand side, so it becomes negative on the right-hand side. Okay, so we just need to be careful with that. That whole term moves across. Okay. There's no more add and subtracts there. So we move along and we look at divide and multiply. Okay, there's no divisions on the left-hand side, they're all multiplications. We're wanting to leave b itself. So we're wanting to take that whole 3p over. Okay, again, that negative 3pb is just negative 3 multiplied by p multiplied by b. Okay, so it's the number negative 3 multiplied by the letter p multiplied by the variable b. Okay. Move them together. Has to divide that whole term. Okay, questions for this on page 28 of that booklet. Okay, just because of the time, I'll just continue. I won't give you any time right this second. What I want to pick up in are these ones here. Okay, when you've got the format of this expression, well, let's just do D first. Okay, we've got that expression S equals A plus 2. Okay, and we want to get to X. Okay, so how do we go about doing that? Okay, and what does X mean? Okay, so let me just copy that down. Okay. do a couple of these. Okay, so that one first. Okay, so we're swapping that around. We want to leave X, so we want to isolate X. Okay. So X is a division, okay, and it's dividing that whole term above. Okay, it's dividing that whole term above. Okay. We want X on the left-hand side, okay, but we want it not to be a denominator. Okay, and by denominator, I mean we don't want to be left with 1 over X. Okay. We can rewrite that. So X equals 1 over X multiplied by A plus 2. Okay. That and that means the exact same thing. Okay, so we don't want to be left with that. We want X on the top line. Okay. What I'm going to do here, first step I'm going to do is take that X and actually move it over to the left hand side and leave the A plus 2 on the right hand side. Okay, so it's a divide on the right hand side. If I move that over with the S, okay, it becomes a multiple. It becomes XS equals A plus 2. Okay. You might look at that first term, you might go, well, there's an add there, so why can't we move that? Why are we not getting rid of that? Okay, remember that X, because the length of that line, okay, that means that X is dividing that whole term, that A plus 2. Okay, so we can't get rid of that 2. Because that would affect that expression effectively. Okay, so we need to get rid of that division first. Okay, because it's dividing that whole top line. Okay, so we've brought the X to the other side, just so it's on the top line, it's not a denominator anymore. That gives me XS plus, well, XS equals A plus 2. Okay, so to leave X on its own, I can just move this S now. Okay, and that S is a multiple on the left hand side, so when I move it over to the right, okay, again it divides that whole term, that A plus 2. Okay, so the length of that line is really important. After the sound, that's one of the common things that throws you. Okay, we'll go back into this. Okay, and we'll look at it again. So if I go on to G now, and then we're trying to solve this to find X. Okay, what order do we need to do that? Okay, so if I go into, if I just write that down. A equals X plus 8. A equals X plus 8. Okay. We're wanting to leave X on its own. Okay, so we want to isolate X. That X is on the top line. That top line is a whole expression itself. Okay, so that X plus 8 has to stay whole, and we need to get rid of that division first. Okay, so first thing, like the first few times I did, we want X to be in the correct side. So I'm just going to flip that expression, but keep it all the same. Okay, so I've not changed anything there. not changed any signs or anything. I'm just putting X on the left-hand side, but keeping it all the same. Okay, so I've not changed the form of that expression at all. Okay. So that up top has to say solid because that divide by 9 is dividing that whole line. We need to move that 9 first. Okay, it's a divide on the left, so it becomes a multiple on the right. Okay, and now, and only now, we can move that plus. Okay. And then the last one in that booklet, okay, was this type. Okay, so let me just copy that down. These are the ones that people mix up, which is why it's quite good to have them for practicing. So y equals 2 divided by x plus 1. Okay, now remember, that is not the same as y equals 2 plus 1 over x. Okay, they are different. So we need to treat them differently. Okay, this time x is only dividing the 2. So only that number 2 has been divided by the x on the right hand side. Okay. What I want to do here. Okay. This follows BODMAS, so we can move the add or subtract over. Okay, I'm going to keep everything on the same side and you'll see why in a second. Okay, we can move add or subtract over. So it becomes y minus 1 equals 2 over x. Okay. I don't want to leave that x at the bottom. Okay, now I could move that 2 over and it would become but that's just messy and it looks horrible. Okay, so that's mathematically correct, but we want to leave x as the top number, the top character, sorry. Okay, so I could move that 2 over and leave x on its own. Okay, so technically isolated x. Okay, remember to put that. I want to leave it in the top line, so I'm going to move the x across to this side. It's a divide on the right hand side, so it becomes a multiple. Okay, and it multiplies that whole term. Okay, so just as the ones before, we've divided that whole term. Okay, that x comes over and it multiplies that whole term, that whole thing. Okay, on the left hand side. That means I can move that over as one term. Because I've got that in brackets, I can move that as 1. Okay. X equals 2 over y minus 1. Okay, so those last 3, I've just done the 3 different ways you can get sort of confused by that or mix up. Okay, so just be aware of them, just be conscious of them, and just make sure, okay, am I doing the right thing? What are we trying to divide here? Or what is being multiplied here? Okay, does that expression, that y minus 1, does that stay together? Okay, in what order? Okay. That's actually a good one to sort of go through. Okay, so remember the answers down the bottom. Okay, so right at the back of the booklet. Okay, so just have a wee double check. So D, E, and F should be similar, GHI and JKL. Okay, those three. Quite a good question to have. We've not done any of the fives. They're quite similar. Right, I'll do one of the question fives. Okay, so I'll just do question A. B equals half C. I'll do question J. So I'll do question A and I'll do question J. And we're changing the expression to show C. Okay, so I'll do question A and I'll do question J. So y equals 10 C minus x. Okay, so we've got B equals a half C and we want to change it to C. Okay, the only reason I've done that is the half's just written in a format that we're sometimes not familiar with. Okay, we sometimes see it, sometimes don't. That is the exact same as writing C over 2. Okay, essentially all it's saying is it's B equals, I'll write it underneath. Okay. What we're saying is a half, getting late. It's a half multiplied by the variable C. Okay, so we can write that any of those three ways. They're all mathematically correct. Now you wouldn't see that in algebra. Okay, you wouldn't use a multiply sign like that in front of a letter. Okay, but that's what it means. Okay. We are more familiar with that sort of format. So if we got asked to move that across, we just move that to across, no problem at all. Okay. Writing it out like that might just throw you a wee bit. Okay, but that's all it means. So if you see that written out, all you need to do is throw that 2 over to the other side. It's a divide. So it becomes a multiply on the other side. And then it's like that. Okay. Just a neater way to write it would be C on the left hand side, it would be 2B. Okay. Those two lines are the same. So on the top two lines. Okay. This format, okay, just be careful with what you're doing with that 10th. So it doesn't mean a 10th and that's dividing that whole term. Okay. Another way to write that would be y equals C over 10 minus x, and then it just becomes the same as the format we did last, or the previous question. Okay. We were to isolate C. Okay. If you want, you can flip it at this point so the C is in the right location, but not change anything. Okay. Then you can have C over 10 equals y plus x. C equals, and this is where you move the 10 over and it multiplies that whole right side. Okay, so it becomes 10 bracket y plus x. So it multiplies everything on that right hand side. Okay, so there's a couple of things in there that could throw you. Okay, just the way it's been written out. Okay. Last thing.
Daniel, sorry, Daniel, before you move on,
Yeah.
can I just ask, why does the half become a 2?
Here,
In that first question?
because it's a half is just 1/2. Okay, so the 10th, so it's just C over 2 in this one.
Yeah, you've
So-
got 2b equals C. I just wondering how we get from a half to 2, because 2 is a whole number, isn't it?
So
Too big.
if you move that, so say you started,
It's a divide from that side to
Yeah,
a multiplication.
so say you started
Right.
with that, and you moved
Uh-huh.
the 2 across, it would become a divide.
Mm.
Okay. So if I started with 2b equals C, if I move that 2 across, it become C over 2. Another way to write that would be B equals a half times C.
Yeah.
Okay, so
Okay.
it's the same thing.
Same thing. Okay, thank you.
Okay. Let's just put that down to it being 49. Okay. The last thing really is dealing with powers and dealing with roots. Again, we've done quite a lot of these over time. Okay, just by doing surds, you deal with these, doing indices, rules of indices, rules of surds, you move that, okay, but they just have it in slightly longer questions, okay, or just slightly unfamiliar questions or formats. Okay, so if we had L equals 5t squared minus 4n, okay, and we want to rearrange that and be left with t. Okay, so we want to be left with t equals. Okay, so I'm going to flip that straight away. So t is on the left hand side. Okay, so 5t squared minus 4n. That's just a nice to have. You don't need to do that. You could deal with t always on the right hand side and move everything across. Okay. What do we move first? Okay. So we're dealing with the whole time, we're always dealing with BODMAS. We're rearranging, so we're going right to left. Okay. We're dealing with our add and subtract. So this term here moves across. Okay. Deal with our multiple. Okay, so that 5 moves across and divides that whole term. Okay. And then we deal with the order of the bracket. So we're dealing with the O, which is order. Okay, so t squared is to the order of 2. You all might also see it written out as BIDMAS, which is the index. Okay, that might be more familiar with that terminology. Okay, but that's what O means. Okay, so we're moving that 2 over. And it needs to root that whole term. So everything underneath that has to be underneath that root. Okay, and that's very important. Again, if we move that across and we just did that, that is not the same. Okay, that's very different. We need to root everything on that right hand side. Okay, you can't just do a wee tiny root. In an exam, just exaggerate it. A big, massive whole page root. Nah, don't do that, but just be very cautious at how long, like the divide we were talking about earlier, how long this root is. Make sure it covers that whole expression. Okay. Same with cubed root. Nothing changes with cubed root. Okay, so we had v equals nt cubed minus 4p. It's a bit similar, but we'll go with it. Okay, we want to be left with T, obviously. Okay, we want to be left with T. We follow the same practice. Okay, so nt cubed minus 4p, just so that we end up with a nice, neat expression. Okay, we follow our bond mass again. Add and subtract. Okay, there's a subtract, so we want to move that. Okay. Divide or multiply. Oh, yep, there's a multiply. Okay, so we get rid of that. Dividing that whole term. Okay. Brackets are order. Yep, there's an order. So we get rid of that. Okay. Remember, cubed root is written the root sign, but with a wee 3 in front of it. Okay, now that's just a wee small 3. Okay, just above the tick mark. Okay, just a wee small 3. Okay, that's v plus 4p over n. That root sign needs to cover that whole thing, remember. Okay. Very common way to write that out would be, and this is wrong, by the way, would just be doing the top line. Okay, divided by n. You wouldn't get a mark in the exam for that because that root sign doesn't clearly take into account that whole expression. Okay, so it's not long enough. So you really need to be careful, okay, that it covers that whole thing. Okay, what that tells the marker is you're only rooting that top line, cube rooting that top line. Okay, so just be very careful with that. Right, it's getting late. Let's hold it there. Okay, we should have enough knowledge to have a good go at them. Okay, so remember answers at the back. There's a couple of exam questions actually, so tell you what, next Tuesday I'll start and we'll go through a couple of these exam questions, but certainly have a go at them. Okay, again, it doesn't tell you what past paper it's from, but they should be from past papers or exam level. Okay, so you can see that it's quite tricky. You're throwing in roots, you're throwing in squares. Okay, so there's a lot going on, so have a good bash at them, work your way through it, and just take it one step at a time. Okay, one step at a time. Okay. That'll be a fun weekend. Have a bash. If you can't see it, don't panic yourself with it and fritter away time. Okay, park it. We'll start again on Tuesday by going through a couple of them, and then we'll move on. Okay, sound good? Stop share. Okay, guys, any questions before we leave it there for tonight?